guys, we're going to do our lesson 3.13 is kind of how I organize it in your notebook. It is converting linear equations from standard form to slope-intercept form. Okay, I'm pretty sure I put a little clip in there about standard form in the web quest or whatever we called that thing yesterday, the video quiz. So obviously it's easier when your equation comes to you like this, y equals mx plus b. That tells us how we begin our graphing. It tells us how to move between our points, right? So if we can get our equations all to look like that, we're going to be a lot better off when we have to do graphing of stuff like this, okay? This is definitely not in y equals format, right? You've got a 3x, and then you've got a minus y, and then you've got to equal to something else, okay? So you probably recognize the different components of our equation, but they're not in the order that we want them to be. Yeah?
Can I, combine, terms and do a locker problem?
Yes, but what you'll notice, all right, I'm glad you said that. You'll notice, though, that on this side of the locker, you have an x term with a 3 in front of it, and then you have a y. Are we allowed to add x's and y's together? Okay, so I love the idea that you have of being a locker problem. So let's just go back and review, okay? If you have to solve for y equals, it means you're trying to get y by itself, okay? So what you've learned in our previous unit about moving stuff around is going to apply. So I put a couple tips down. You're allowed to move the x term by either adding or subtracting to get it away from that side. You're also allowed to divide by whatever coefficient might be sitting in front of y. Yes? We could, but right now, if this is a locker and you've got two sides that are balanced, the only way to get your 3x away from that side is to do what mathematically? Okay, so that's exactly what I wanted us to think about. If you're moving that 3x, you're saying, okay, I know this is a balanced thing, so in order to get it off of this side, I've got to get it off of this side. And if that happens, I'm in pretty good shape, okay? Now, guys, there's two ways to write this, okay? I typically put the x term in front, and then I put the constant term at the end because that's how we talked about y equals mx plus b, okay? Technically, it's not wrong because I will have some students that bring the 6 straight down, and then they bring the minus 3x over behind it. Okay, see how those are the same thing? It's just changing the order. Here's the problem, though. Some kids do this. Okay, are we supposed to have a positive 3 slope? Okay, are we supposed to have a negative 6y intercept? Okay, so the one thing you can't do is change the sign of the numbers that you're working with. You can't just magically float it to the other side because you don't want it on the side with y, okay? You still have to use inverse operations, and you still have to make sure that you're moving things like mathematically correctly. Yes?
Do we have to do a locker problem to rewrite it?
Some kids are really good with their algebra, and they can kind of see where stuff belongs. When I'm first showing this to you guys, I do want you to write stuff down, okay? Because after you get some practice, then, yeah, you'll probably be able to move stuff accurately. But, like, this one's way more complicated because see how you've got your two terms on this side? You can't combine them? Okay? Focus on just the x term first. Notice how it's a positive x? What's the only way to get rid of a positive x? Okay. So if you subtract the x, what do you still have over here, though? You have negative 3y. Okay? On this side, are you comfortable putting the x term in front and then putting that positive 9 in the back? Okay. If you are, you're actually setting yourself up to be done a lot quicker because, again, this is kind of what we like to have when we're ready to graph, okay? We're not graphing today. All we're doing today is making sure we comfortably can solve for y equals. Okay, we'll do more graphing tomorrow. At the bottom, I want to point out this step up here that I talked to you about already. Remember how if you have a coefficient of y, you can do some division? Because, Sarah, what do you think we should do here at the bottom? Okay, so are you comfortable with why I wanted to move the x away from that side of the equation? Okay, I wanted to get my y term by itself. Well, my y term is by itself, but I don't have exactly what I want, which is plain old y equals, okay? So one of the things you can remember is when you're dealing with algebra, if you have a number and a letter tight together, they're attached by multiplying, right? So what's a good way to get that negative 3 out of there? Okay, here's the deal. You not only have to divide that by the negative 3, you have to divide that by negative 3 and that, okay? So, well, here's what we're going to go over, okay? Remember how when you have a variable and it's just kind of sitting there by itself, we can draw in an invisible 1, okay? So you do have something that can divide. What's negative 1 divided by negative 3? Okay, it's not exactly 3. It's going to stay 1/3. Isn't a negative divided by a negative a positive? Okay, do we really want to go into decimals? Okay, no, we want this to be our slope, our rising and our running. So to clean it up, we're just going to have 1/3, which is now positive because negative divided by negative. And then does this clean up nicely? Yeah, 9 divided by negative 3 is negative 3. So guys, do you see how we can kind of transform that beginning equation? It takes a little bit of algebra, thinking about opposite operations, right? But can you get it to be a y equals? Yes, you can have a slope, you can have a y-intercept just from that. Nice. Okay, so we're going to take a look over here. You've got question number 3 at the top over there. It is also going to be looking like a locker problem, but what do you notice that you should probably get rid of first? The 2x term. Very good. So if 2x is positive, we're going to subtract 2x. We're going to bring down, it's not just y, it's negative y. And then are we comfortable in putting this negative 2x term in front of the constant term, positive 4? Okay, so don't forget, the 2x is what's negative, not the 4. Okay, you still have to bring down a plus sign. So guys, are we done? We got y by itself? Sort of. Okay, we're really close to having y by itself. We actually have negative 1 times y by itself. So again, what can we do if we don't want that negative 1 coefficient? Very good. Divide everybody by negative 1. This gives us our y equals that we wanted. It does turn our slope to being positive 2. And what does it do to our y-intercept? Yeah, it's really a negative 4. Okay, and with that, we can go ahead and we can graph, right? Okay, again, not worrying about graphing today. What we're worried about is being able to do this type of locker problem so that we can just solve for y equals. All right, so this one, 3x plus 5y equals negative 10. All right, there's a lot over there, so start small. Always move your x term first. So how are we going to do that? Subtract 3x. You got it. Okay, be careful. Can we put x's together with plain old numbers? Okay, so that's what's weird about these, okay? When you guys were doing equations at the beginning of the year, when you moved your x term, you were subtracting it from another x term, right? Well, these things typically don't have another x term. Typically, they have a constant term on this side, okay? So I'm really glad you brought that up because a lot of kids do forget that part. So are you comfortable bringing down the negative 3x, but also putting that negative 10 behind it to keep the parts separate? Okay, most of the time these will be non-proportional equations, okay? Every once in a while you get a proportional one, but I think non-proportional. So guys, are we done with this one? No. Okay, we still have a 5 that's our coefficient. So right, you're going to divide everybody by 5. And guys, what's going to happen sometimes? All right, you're going to see a fraction like this, okay? That's not going to divide nicely. I mean, you could turn it into a decimal, 0.6, but do we really want decimals when we're working with slopes? Okay, is this going to turn positive on us like that other one we did? No. Negative divided by a positive is going to stay negative. And then what about back here? Okay, this will typically give you a whole number, but not always. Okay, it's possible to have y-intercepts that are not whole numbers. In science, I'm sure you've done some graphing where you don't have a whole number as your y-intercept, right? Sometimes you have to work with decimals anyways. Good? Okay, so last one, I hope I didn't cover it up. It says 3x minus y equals 15. So what are we going to do first? Good. Get rid of that x term. We said you're always going to start out by doing the easiest thing. Add or subtract the x term. Once you get that big thing out of your way, you can really focus on what's left. We have our y, we have our negative 3x, and we have our 15. We're done, aren't we?
No, we can divide by 1.
By
Negative 1.
what kind of 1? Okay. So yeah, what you got to be careful is after you move that x term, you got to remember that you are not done if that's still a negative y, which it is. So because it's negative 1y, you are dividing by negative 1 all the way across. And what does that do to your final answer?
3x.
Right. Makes positive 3x. It makes negative 15 for your y-intercept. Okay? Got the idea? Awesome. If you wanted to, yeah, you could say I'm going to add a negative 3x instead of just subtracting 3x. You got it. Yes.
Do you care if I do plus negative 15 or?
If you do plus negative 15, that works. Yep. Plus negative 15 at the end definitely works.